And on the awesome tutor, today we're going to be looking at resolving. Resolving is key in mechanics. It is the backbone of everything. Okay? You're going to be resolving so much mechanics, you should be able to do it in your sleep. So, say this is a table, this is a book, whatever. The force is not acting directly vertically or directly horizontally. It is acting at an angle theta. So, it basically forms a right angle triangle, with the force being the hypotenuse, the angle theta, and our vertical forces and our horizontal forces. So, using trigonometry, sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse. So how do you find the vertical force and how do you find the horizontal force? We resolve. The vertical force is the opposite. So sine theta multiplied by hypotenuse, which is the force, gives you that opposite force, which is the vertical one. So F times sine of theta is your vertical force, okay? F is the hypotenuse. Rearrange it. You want to find the opposite because that is the vertical force. Same thing for the adjacent, which is the horizontal force. It is equal to F cosine of theta. So let me give you an example. Okay, so we have a particle and the force that's pointing in this direction is 12 newtons and the angle between the direction of the force and the direction of motion of the particle is 20 degrees. So say the particle was moving this way, we have to find this angle. So, let's find the vertical force and the horizontal force. So let's resolve vertically. The vertical force will be 12 sine of 20 degrees. Okay? Opposite over hypotenuse. That is sine. And the horizontal force is 12 cosine of 20. Adjacent over hypotenuse, rearrange it. Hypotenuse multiplied by cosine gives you the adjacent, which is the horizontal force. So your vertical force is 4.1 newtons to 3 significant figures, and your horizontal force is 11.3 newtons to 3 significant figures. Okay, I'm going to give you another example. We have the particle here, it is moving in the direction of the x-axis. The force acting on it is 4 root 2 newtons. The vertical force is 3 newtons. Find the angle between the direction of motion and the force. So that's this angle here. Alright, pause the video, have a go at it, and then I'll go through it. So this is your triangle, this is your force, this is the vertical force. So sine theta is opposite over hypotenuse. Inverse sine, you get theta is equal to 32 degrees, rounded to the nearest whole number. Okay, resolving proves much more useful when we're talking about a particle moving up or down an inclined plane. So if this is the angle that the plane is inclined to, theta, and the reaction force, R, has to be perpendicular to the plane. Okay, because the force exerted from the plane onto the particle. Now the weight of the particle is always down, mg. So how do you find the forces making the particle go up or down the plane, and the forces that are perpendicular to the plane? So the question might ask you to find R, or the question might ask you to find the forces going up and down the plane. So first of all, how do we find R? If we draw a line perpendicular to the plane here and make a right angle triangle, this angle here will be theta, the same as this angle. I can prove it to you, but I'm not gonna because there's no time. So this is our triangle. Theta, mg is the hypotenuse. So these are the forces perpendicular to the plane, and these are the forces that go up and down the plane. So the same sort of principle, sine theta is opposite over hypotenuse. So the forces going up and down the plane will be mg sine theta. That is resolving up and down the plane. Resolving perpendicular to the plane, we have mg cosine theta. Okay, because cosine of theta is adjacent over hypotenuse. Rearrange it to get your adjacent force, mg cosine theta. So let me give you an example question. A particle is on a plane inclined to the horizontal at 26 degrees, and the reaction force is 12 newtons. Find the mass of the particle. So here's the weight, mg. Let's do our triangle. That is 26 degrees. So, to find the mass of the particle, first of all, we already have r, which is 12, okay, because r is equal to the forces perpendicular to the plane. Okay, because say the particle is in equilibrium, okay, so it is stationary. The r will be equal to the forces perpendicular to the plane, and it won't be moving up and down. Now, realistically, it will be moving up or down, and r will still be the same as this force. Otherwise, the particle will be moving or floating off the plane, or it will be moving into the plane, which makes no sense, unless there is another external force. So back to the question. R is equal to this force. So resolving for R, we get R is equal to cosine of theta adjacent over hypotenuse. So mg cosine 26. Okay? So let me go through that again. Cosine of 26 will be adjacent over hypotenuse. So the adjacent force is mg cosine 26. Okay, we know what r is. That is 12. So we just rearrange it, and we get m is equal to 1.3623 blah 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 blah. We use 9.8 for g, which is the two significant figures. So our answer will be to two significant figures. So m is 1.4 kilograms. Let's go through another question, but this time with forces and acceleration. So a box, a particle, whatever, its model is a particle. It is being pushed up a plane inclined to the horizontal at an angle of alpha, where tan of alpha is 3/4. It is being pushed up the plane by a horizontal force 20 newtons. Find the normal reaction. First, let me complete the diagram. We have our normal reaction. We have our weight, 20g, and we have this triangle I told you about, where this is alpha. Okay, so this 20 newtons is no use to me because it's horizontal. And for this question, we need forces that are going up and down the plane or are perpendicular to the plane. So we need to resolve. So this will be our triangle. How do I get to that? Well, here's the plane. That's the plane. And that is alpha. Okay, because of the z-shaped parallel lines, this angle is equal to this angle. So the forces going up and down the plane will be this line. Forces going perpendicular to the plane will be this line, creating a right angle triangle, which is the one you see here. So, how do we find x and how do we find y? So 20 is our hypotenuse, x will be the opposite, and y will be the adjacent. So sine of alpha is opposite, which is x over hypotenuse. So to get the x, to get this perpendicular force, it is 20 sine alpha. We have resolved perpendicular to the plane for the 20 newtons. Now, for cosine alpha. Cosine alpha is adjacent, which is y, over hypotenuse, which is 20. So, rearrange it, y is equal to 20 cosine alpha. We have now resolved up and down the plane for the 20 newtons. So, back to the actual question. So it tells us that tan of alpha is 3/4, but we don't use tan of alpha in this question. We are constantly using sine of alpha and cosine of alpha. What are the values of those? So here's a right angled triangle, completely separate from the diagram, has nothing to do with the actual question, just a way to find sine alpha and cosine alpha. So we know that tan of alpha is opposite over adjacent, which is 3/4. Opposite over adjacent. So we can find sine of alpha and cosine of alpha. I know that this is a Pythagorean triple, a 3, 4, 5 triangle. If it was something else, I'd just use Pythagoras to find the hypotenuse. So sine of alpha we know is always going to be opposite over hypotenuse, which is 3/5. Cosine of alpha is going to be adjacent over hypotenuse, which is 4/5. So now we have our values for sine alpha and cosine alpha that we can substitute into our actual calculations. Alright, now to actually find r. If we resolve perpendicular to the plane for every single force, okay, what are the forces going up, going in this direction? That is r and nothing else. What about the forces going down into the plane? We have the weight of the particle, but we need to resolve that too. So if we resolve it, it's going to be 20g cosine of alpha, because cosine of alpha is adjacent, which is this force we're trying to find, over hypotenuse, which is 20g. Rearrange it, 20g cosine alpha. Plus the resolved forces we found for the 20 newtons. So this force we're going to look at, 20 sine of alpha. We know what cosine alpha is, we know what sine alpha is, so we substitute in these values, we get r is equal to 170 newtons to 2 significant figures. Why 2 significant figures? Because for g, we use 9.8, which is to 2 significant figures. If you're using 9.81, put your final answer to 3 significant figures. So it'll be 169. Okay, now we need to find the acceleration of the box up the plane. So we use force is mass times acceleration. Let's take the forces up the plane. We'll use that direction. So what are all the forces going up the plane? We have the resolved force from the 20 newtons, which is 20 times cosine alpha, which is 16 newtons. So we have 16. What about all the forces going down the plane? We have the weight, the resolved force for the weight, which is 20g sine of alpha, because sine of alpha is opposite, which is the force we want, over hypotenuse, which is 20g. Rearrange it, you get 20g sine alpha. We know sine alpha is 3/5, so it's 117.6. Is equal to the mass, which is 20 kilograms, multiplied by the acceleration. Rearrange that, you get A is equal to, you get negative 5.1 meters per second squared. So the 20 newtons horizontal force is actually not enough to push the load up the plane. So it's actually going down the plane, it's accelerating down the plane. Okay? I think this was supposed to be 2 kilograms, not 20. which is why it's accelerating down the plane. So I wrote down the question wrong. Doesn't matter, still all the values for this altered question are still right. This has been the Awesome Tutor. Bye.